So today I get to introduce atomic physics and let's talk about the atom. So of course from our notes here we can, here I'm explaining simply these notes. So from our notes we can see that an atom is defined as the smallest electrically neutral particle. Electrically neutral particle of an element that can take part in a chemical reaction. And from here we can see that they're telling us that the atom consists of what we call the proton, the neutrons, and the electrons. So let's first talk about those three in greater detail. So I'm going to draw a diagram here and I'm going to illustrate these. This is what you need to know overall. So the black circle is what we call the nucleus. And then what I am drawing around the nucleus, these red circles, are what I am calling the energy shells. These energy shells are around this black circle. Now, what is inside the black circle? Inside the black circle, we have what we call the protons. And also inside the black circle, we have what we call the neutrons. And so these are the so-called the protons here and the neutrons there. They are found inside the nucleus. Then what about the electrons? Where are these electrons found? These electrons are found around in the shells. Let me denote them here. So the electrons are found around the nucleus. And these electrons are always in motion. They are always moving around in these shells around the nucleus. This is what we call an energy shell. So when this proton you see right here is actually positively charged, and these electrons are negatively charged. In other words, the negative charges are the ones that keep running around the shell, and the positive charges are always in the nucleus, and this is what we call the nucleus, right? And in the nucleus, it's where we have the protons, which are positively charged, and then we have the neutrons. Now, the neutrons do not have any charge, so their charge is zero. So the protons have a positive 1 charge, the electrons have a negative 1 charge, and the neutrons have 0 charge. That's just how it is. So the notes continue to tell us that this atom, the central part, is made up of the nucleus, and around which electrodes rotate. Electrons, not electrodes, it's electrons. Around which electrons rotate in an orbit or shells, or call them energy levels. Of course, as we continue into advanced physics or advanced chemistry, the energy levels are talked about into detail. At this level, we'll just call it that, energy levels. So the protons and neutrons, these ones are lying within the nucleus, and sometimes these protons and nucleons are called they are called nucleons. In other words, uh, within the nucleus, these particles are sometimes referred to as nuclei particles or nucleons. So they are called nuclei particles or nucleons. If you look at these diagrams here, they are trying to describe exactly what we have been talking about. If I'm to zoom in a bit, we have the hydrogen atom here. It has one proton. Remember, hydrogen is just that. It has one proton. So from there you're able to see. Then we have the helium atom here. So we have helium is written like that, right? It has two protons and two neutrons. Then we have the neon atom like that. And then this neon atom, like you can see. So I want you to take note. The hydrogen proton has one p here to represent one proton. So because it has one proton, remember the protons are the positively charged. Do you notice also that the electron, the negative charge is also 1? So the number of protons here is the same as the number of electrons. Let's go to the helium atom. If you look at the helium atom, it's the same story. It has two protons, meaning that it has two positive charges. And then when you look at the number of electrons, we have 1 and 2. Let me use a different color for that. We have 1 and 2 electrons. So in other words, you have 2 electrons, 2 negatives. So do you realize that we have 2 protons here? In other words, we have two positive charges and also 2 negative charges. In other words, the number of protons in the nucleus is the same as the number of electrons that are running around that nucleus. The same story when we come to the neon atom. If you look at the neon atom, it has 10 protons. Remember, protons are positively charged, so meaning it has 10 positives. And now when you count closely the number of negatives that are running around, we have that one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 negatives. I would like you to take note of that the number of protons they are equal to a number of electrons. And now when the number of protons and the number of electrons are the same, that is what they are referring to here. Let's get back up here. That's what they mean when they say that an atom is defined as the smallest electrically neutral particle. Electrically neutral particle of an element that can take part in a chemical reaction. So this word neutral is what it means to have the same number of positives and negatives like you have seen in those diagrams. So here the positives and the negatives are the same. In other words, the number of protons and the number of electrons are the same. That makes the atom electrically neutral. But is it going to always be the case that they will always be the same? No, they are not always going to be the same sometimes. That is, sometimes these electrons that keep rotating, sometimes they are lost. And when they are lost, it means you have less negatives than positives. And sometimes you find that sometimes you gain more electrons from, more electrons come and join. When more electrons come and join, it means you have more, more negatives than positives. When such scenarios happen, we formulate what we call an ion. But that is not our discussion for today. This will be a discussion for another day. Just know for now that for an electrically neutral atom, the number of protons is equal to the number of electrons, meaning that the number of positives is equal to the number of negatives. And that is what we call an electrically neutral atom. Now, there's something else that you need to observe too. That when you look at the protons and neutrons, they are always at the center. The protons and neutrons are at the center. The protons and neutrons are at the center. And when they are at the center, that is, they are in the nucleus. Now, when we are talking about how heavy this atom is, this is an hydrogen atom. If we want to find out its mass number or how heavy it is, what is its mass number? We are simply going to add the number of protons and the number of neutrons of that atom. Why? Because the nucleus contributes or accounts for more than 90% of the weight of the entire atom. These electrons you see outside here, their weight is negligible. And so because their weight is negligible, we ignore them. And so it means when we want to add up how heavy this atom is or the mass of this atom, we shall simply consider what is in the nucleus. So here we're having 1 proton and 0 neutrons. So meaning that the mass of this atom, the mass is 1 plus 0, which is 1. If you look at this, it has 2 protons and 2 neutrons. I hope you're able to see it clearly on your screen. We have here it is 2 protons and 2 neutrons. So it means its mass number is going to become 2 protons plus 2 neutrons, which is 4. So meaning its mass number is 4. Same thing here. We want to find the mass of this. It's going to be, there are 10 protons, so it's 10 positives plus the neutrons, which do not have a charge. 10 plus 10, which is 20. So 20 means it's the mass number of this, of neon. I hope we are together to that point. So in other words, these neons are the things at the center. That is what determines the mass number of, an atom. Now, another issue. So if that is the mass number, so that is why when they say here that, look at this statement. The statement says that the protons and the neutrons, those are the things that are at the center in the nucleus, they say they lie within the nucleus, and these particles are sometimes referred to as nuclei particles or nucleons. So because they are referred to as nucleons, that's why sometimes the mass number is referred to as the nucleon number, because we are looking at the number of nucleons in the unit in the center. So mass number and nucleon number, it's the same thing. Okay, to get those two numbers, we are simply going to add up the number of protons plus the number of neutrons. As simple as that. So there are two major things that I want you to take note here before we continue with the notes. Two major things that I want you to take note here. Number one is that when an atom is electrically neutral, when it's electrically neutral, the number of protons, that is the number of positives, will always be equal to the number of neutrons, which is the number of negatives. That's one thing. Then two, the other major takeaway that I want you to take is when we're talking about the mass number, or call it the nucleon number, here it is always going to be given by what is in the nucleus. What do we find in the nucleus? In the nucleus, we have the protons and the neutrons. The protons are the ones that are positively charged. The nucleons have no charge. So when you add those two, you end up with the mass number, which is most times denoted by A. So those are the two major takeaways. So if you come down here, you can see here, we're talking about protons, their symbol, it's in the nucleus. This is what we've been talking about: protons, neutrons, electrons, and their charges. Okay, so down here, the atom of an element is represented by that chemical equation using a chemical symbol. So that's the chemical symbol. Let's say we're talking about sodium. We have sodium here, which is written by that. We all know that sodium has a number 23 up here and a number 11 down here. So that 11 is what we are calling here Z, and that Z is what they are referring to as the atomic number. Now, what is the atomic number? The atomic number is the number of protons. So if you look at this diagram here, the number of protons, the positives that are inside the circle. Let me make this clearer. If you look at this diagram here, this neon atom, for example, if you look at it closely, you realize that we are having 10 protons. So if we're having 10 protons, it means the atomic number for neon, if this is neon, so the atomic number is 10. That is what it means. Then let's get back. Then what about the number up? This number up is what we are calling the mass number. And remember, the mass number is a combination of what is in the nucleus. So if we are to go back to our illustration here of nucleus, remember our mass number is going to be what is in the center here. And if in the center here we can see there are 10 protons plus 10 neutrons. So when we add those two, it gives us 20. So it means that the nucleus, its mass number here is 20. So this top number here is the mass number that is representing the total number of protons plus neutrons. The atomic number here is representing the number of protons. Okay, and the number of protons for an electrically neutral atom, the number of protons is always going to be equal to the number of electrons. As simple as that. So that is what it's being talked about here when they say that the atom of an element is represented in a chemical equation using a chemical symbol as shown. This is the chemical symbol. We've talked about this as mass number, which is the same as the number of protons, which is the same as the number of electrons. Then the atomic number, which is the same as the number of protons plus neutrons. So that's what they're trying to explain here. All right. So these are definitions here. What's an atomic number? Atomic number, of course, we said it's the number of protons. Then what is mass number? The mass number is also called the nucleon number because it is a combination of protons and neutrons. In other words, mass number, which is A, is the number of protons and neutrons or in the nucleus of an atom. As simple as that. And then down here, of course, they're telling us these are just formulas about the atomic number. So with that session, I've been able to explain what an atom is and a few elements of it that are relating to the atom.